Good morning, students. Before starting with the new chapter, the human eye and the colorful world, we should remember these points, which is very necessary at the time of COVID-19. Like we should always wash your hand with a soap for about 20 seconds. We should always follow the social distancing. It means the distance between the two persons should be 6 feet. And always wear a mask. We should always wear a mask. It is really helpful for you and your surrounding persons, your family. Consult your doctor before stopping any medication. If you're in medication, if it means if you're taking some medicines, before stopping these medicines, you should always consult your doctor. And if is it possible that you can work from your home, then it will be really helpful for you. And don't ignore your own symptoms. If there is some symptoms about the cough and cold, like the cough and cold, don't ignore it. Should consult to your doctor and take care of your physical and mental health. It means that the exercises are best for physical health. Now, these points should always be in our mind, and we should always follow these rules. Now, the new chapter of the physics, the human eye and the colorful world. In this chapter, the most of the part has been related, like the human eye, the working of the human eye is related from our syllabus, and defect of vision, like the myopia, hypermetropia, presbyopia. These defect of vision has been related from our syllabus during this time of COVID-19. So now the new part of the chapter is, now the part which we have to learn in this chapter is the glass prism. Glass prism. I think you have ever seen the glass prism. It can be possible that you've seen the glass prism. We have learned in the last chapter about the glass slab. You know the glass slab, it is a rectangular glass. It is a rectangular slab. Slab means like the cuboidal. It is cuboidal in shape. Or we know that how the light is passes from the glass slab and what happens to this light ray when it passes from the glass slab. We know that it deviated from its original path. The light which is emerged out from the glass slab is always parallel to the incident ray. So this is the glass slab. And what is about the glass prism? Actually, a glass prism is made up of glass, since the name show that it is made up of glass. And prism, its structure is like this. The base is triangular, the top is triangular, and if we join these points, this type of shape is formed. And this shape is called the prism. This is a prism. It is made up of glass, a solid glass. Okay, I just try to explain you by paper. Okay, just try to understand with the help of this paper. This is a paper, okay? And we make a triangular shape of this paper like this. This is a triangular shape of this paper. Triangular from here and from here. And it has 3 rectangular faces like this. Has 3 rectangular faces and triangular top and a triangular base. And suppose this whole is made up of a plain glass, a solid glass. So this is called the prism. Okay, prism just look like this. This is a prism made up of the glass, of the solid glass. Okay, so this is a glass prism. When a light is passes from the glass prism, for our convenience, we draw it like this. Okay, आपने इसको ऐसे लेटा दिया है ना, तो ये ग्लास प्रिज्म है. इमेजिन करो कि इस तरह से पीछे से है ये. तो हम अपनी कन्वीनियंस के लिए, फॉर कन्वीनियंस, वी ड्रॉ द ग्लास प्रिज्म लाइक दिस. So what happens when the light is passes from the glass prism? It deviated like this. When it passes from the glass slab, we know that the deviation of the light takes place because the refraction, due to the refraction of the light. And what happens in case of glass prism? Actually, the light is also deviated in the glass prism. If we pass a light from a glass prism, what happens? Okay, I'm making a large figure for it so that you can easily understand. This is the incident ray. You know, the light ray which is coming towards the prism is called the incident ray. Incident ray. This is the incident ray which is coming towards the glass prism. And since it falls at this point, so we can draw the normal at this point. This is the normal, this is a perpendicular line on this surface. Now the light is passes from the air into the glass. What will happen? We know that the reflection of the light takes place. So it passes from the rarer into the denser medium. It bent towards the normal. So this is the normal. Okay, for this surface, this is the normal. The light which is coming with this certain angle will deviate it and bend towards the normal. Okay, so this angle is less as compared to this one. This is angle of refraction, this is angle of incidence. So angle of refraction is less as compared to the angle of incidence, because the light is bent towards the normal since it passes from the air into the glass. Okay, now again, what will happen if the light passes from this glass into the air? Again, the reflection of the light takes place, because glass is a denser medium, air is a rarer medium. So at this point where the light is falls on the surface, we draw the normal. This is the normal for the surface. Okay, then what will happen? The light will bend away from the normal since it is passes from the denser into the rarer medium. This angle is less as compared to this one. So you saw that the light, this is the incident ray, and this is called the refracted ray. Refracted ray. And this is called the emergent ray. Emergent ray. This is the emergent ray. Okay. So this is called angle of incidence, angle of refraction. Here is the angle of emergence. So the light which is coming is actually, after traveling through the glass prism, is passes like this. And this is the incident ray. And this is the emergent ray. If we meet these points in backward direction, so this is the actual path of the light ray which it should follow, but the light is banded in this direction. It means this is the deviation of the light takes place. I think I should make another figure for you so that you can easily understand it. This is a glass prism. इसमें बहुत सारी मार्किंग हो गई है तो समझ में नहीं आ रहा है. देखो, ये इंसिडेंट रे है, ये नॉर्मल है, ये बैंड हो गई टुवर्ड्स द नॉर्मल, और जब ये बाहर निकली है तो फिर से ये एमरजेंट रे हो गई है. तो द एक्चुअल पाथ ऑफ द लाइट इज दिस वन. दिस इज एक्चुअल पाथ ऑफ द लाइट रे, बट आफ्टर ट्रैवलिंग थ्रू द ग्लास प्रिज्म इट पासेस लाइक दिस. सो इट मीन्स ये तो जाना था पर ये चली गई है ना, यहाँ से आके ये चली गई है. तो दिस इज द डिवीजन. दिस इज कॉल्ड द डेविएशन. इट इज एक्चुअली कॉल्ड द एंगल ऑफ डेविएशन. एंगल ऑफ deviation. Okay, we represent it by using the symbol delta. This is called the angle of deviation. Okay, I think you will now you understand how the light deviated when it passes from the glass prism. So you can write the definition of the angle of deviation. Please write down the definition of angle of deviation. Angle of deviation. The angle between incident ray and emergent ray. Emergent ray is called angle of deviation. Angle of deviation. Okay, and we represent it by using the symbol delta. This is the angle of deviation. I think it is easy to understand why this type of angle of deviation is not formed in glass slab. We have learned in last chapter that in the glass slab what happens actually, the light which is coming from air into the glass is bent towards the normal, and it passes from the glass into the air, again it bent away from the normal. So actually the light which is coming to this path is deviated like this. So here the emergent ray and the incident ray are parallel to each other, and the distance between them is called the lateral displacement. And why the light rays are actually parallel to each other? Because the glass slab is, the opposite faces are parallel to each other. But in case of the glass prism, these faces are not parallel to each other. Since these faces are not parallel to each other, so the light is actually deviated. Here, the light do not pass parallel. Here, the emergent ray and the incident ray are actually not parallel to each other. Certain deviation take place in the light due to this angle between the two faces. Okay, if these faces will parallel to each other, the light will be passes. The emergent ray will be parallel to the incident ray. Okay, now, now for the white light. What happens when the white light is passes from the glass prism? Let's try to understand it. If you get any problem in any part, you can ask in your group. Now the dispersion of the light. You know the dispersion of the light? Dispersion of light. We know that the white light is made up of seven colored light. You know, in 1665, first the scientist Newton, who discovered that the white light is made up of the seven color. Now it is very simple to us that we know that the light is made up of seven color. But first, the scientist who discovered that the light is made up of seven color was the Newton. So Newton discovered that the light is made up of seven color. So how he able to find that the light is made up of seven color? Actually, when the light is passes from the glass prism, it disperses into its seven color. Now we will try to understand why the white light disperses when it passes from the glass prism. This is the incident ray. Okay, and we know that the light or the white light has made, now we know that the light is made up of seven color, and these seven color have same speed in air and in vacuum. All the colors of light have the same speed. But what happens when the light is passes in different medium, like in glass? When the light is passed in a glass, the different colors has different speed. In air, all the color have the same speed, but in glass, different colors has different speed. Now, what will happen? Now, let's remind our first chapter conclusion. That is, when the light is passes from the medium 1 to the medium 2, suppose medium 1 is the rare medium and medium 2 is the denser medium. Now, what will happen? We know that the light is bent towards the normal. And on which factor this bending depend? Actually, how can you differentiate that the light will bend more or less? Let's take one example. This is air. Okay, in all these two examples, the first medium is the air. We know that air is a rare medium. And this medium is suppose this is a water. As compared to air, we know that water is a denser medium. And this is a glass. Glass is another denser medium. Okay. Now we know that the water is less dense as compared to the glass. So we know that the air, when the light is passes from the air into the water, it bend towards the normal. है ना? It's very clear because this is an denser medium. Again, suppose these angles are equal. Suppose the angle of incidence are equal for both. Now again, when it passes from air into the glass, it will bend more as compared to the water in glass. You know why? Because in last chapter we have just studied that the speed of light in glass is less. The speed of light in glass is less as compared to the speed of light in water. So it means the bending depend on the speed. As the speed of light is less as compared to another one, the banding is more. जिसमें जितनी ज़्यादा कम होती जाएगी स्पीड उतनी ज़्यादा बैंडिंग होती जाएगी. Is it clear? Now, again, come to the point, glass. What happens when the light is passes from the air into the glass? Different colors of light have the different speed. Now, the speed, the light which has the maximum speed. You know which color has the maximum speed? The red color of the light has the red color of light. Red speed is maximum and the speed of the light of violet color is minimum. So you can easily understand, if the speed of light is red is more as compared to the speed of light is violet, what will happen? Here in this example, we know that the speed of light is water is more as compared to the glass. So the bending in glass is more. It means the speed of light is red is more as compared to the speed of light of violet color. It means the bending of violet color will be more as compared to the red color. Is it clear? So what will happen when when the light is coming and it travel into the glass? The seven color of light, since these colors have the different speed, it is split into its seven color. And the light which has the maximum speed of light in glass deviated less as compared to the light which has the minimum speed, the light of the color of the light which has the minimum speed in glass. It means the red color has the highest speed, so the deviation of the red color is less as compared to the violet color. So that's the reason why the light is split into its seven colors when it passes from air into the glass. And this dispersion, again, what will happen when the light is passes from the glass into the air? Again, we know that when it passes from the glass into the air, this is the denser medium, this is the rare medium. Again, the bending of the light takes place, and we find the seven color split. The white light is split into its seven color. Vibgure, we represent it by using the Vibgure. It is easy for us to remember. Vibgyor. And what is the meaning of this line? V means violet, I indigo, B blue, G green, Y yellow, O orange, and R is for red. So this is the Vibgure. This is the band of the seven color. And this type of dispersion of white light, this is called the dispersion of white light. When the light is passes from the air into the glass, is split into its seven color, and this is called the dispersion of the white light. I think it should be clear to you why the dispersion of white light takes place when it passes from the glass prism. Now write some important points about it. First of all, write the definition of a spectrum of white light. Spectrum of white light. What is the spectrum of white light? Actually, this band which is formed when the light is passes from the glass prism, and this band is called the spectrum of white light. So write down the definition. The band of seven color formed on a white screen when a beam of white light is passed through a glass prism is called spectrum of white light. Okay, of white light. The one question can become in your mind, if we take the another medium for the prism, like the in place of glass, suppose we make a prism of water. I know it is not possible, but another medium, let's take another example. So what will happen? The dispersion of light takes place if we take another medium other than glass. Yes, if that medium is optical medium, it means the if the light is can passes through through that medium, and it is denser, the dispersion of light obviously takes place. And in daily life we observe the dispersion of light also takes place through the water in fountains. Have you ever seen in fountains, near the fountain, the rainbow is, we always saw type of rainbows formed, and this is also the dispersion of the white light. Okay, this is definition of the spectrum of the white light. Now write the definition of dispersion of white light. For अगर आप चाहते हो कि आपको कोई भी चीज़ हमेशा याद रहे, तो एक चीज़ का ध्यान रखना, हमेशा आप जिस भी चीज़ को समझ के याद करते हो वो आपको हमेशा याद रहती है। Dispersion of light. So write down the definition of dispersion of light. The splitting of white light is splitting of white light into 7 colors on passing through a transparent medium. Okay, this medium can be glass, it can be water, it can be any transparent medium which should be denser, like a glass prism. Glass prism is called dispersion of white light. This is called the dispersion of white light. Okay, so this is the definition of the dispersion of white light. Okay, now I think you know why the dispersion of white light takes place. So this is a question for you. You have to write it. Why the dispersion of light takes place when it passes from a glass prism? What is the cause of dispersion? So you have to write the cause of dispersion. What is the cause of dispersion? Okay. I think I should again I should explain you why the dispersion of light takes place. Since the different color of white light have the different speed in another medium like the glass. Since the different light has different speed in other medium other than air, so the dispersion of light takes place. And I think you should write it. Okay, the answer of this question you have to write yourself. What is the cause of dispersion? Now, this is an important point. You should always remember that the mm, the red color of white light has the maximum speed so the red color is deviated the least. Okay, since the speed of red light is maximum in other medium. Okay, sorry for that. Okay, since we know that the red color has the maximum speed in glass, so it deviated the least. And the blue color has the minimum speed in glass, so it deviated the most. Okay, so please write down again. The violet color has the minimum speed in glass prism, so the violet color is deviated the maximum. So it means this is a cause of dispersion of light. Since the different color has different speed in different medium other than air, so the dispersion of light takes place. And the light which we find at the bottom of the spectrum is the violet color, because it has the minimum speed. And at the top of the spectrum we find the red color of light, because it has the maximum speed in glass. Okay, so this is called the dispersion of white light. and this type of band which is formed on the white screen is called the spectrum of white light. Okay, now we know that, okay, what is the glass prism and why the deviation takes place of the light when it passes from the glass prism. We know that when it light passes from a glass prism, it deviated towards the normal of the glass prism, and we know why. Now, what is the dispersion of white light? The scientists who first discovered how the dispersion of light takes place here, why the dispersion of light takes place when it passes from the glass prism. Okay, now continue. What happens if we recombine the two glass prism? Suppose this is a glass prism, okay, and this is another glass prism. One thing you should remember when you recombine the white light, that this angle of prism, this is called the angle of prism. Okay, this angle of prism should always be equal for the recombination of white light, and the okay these angles should be equal, and we will place like this. ये लाइन इसके पैरेलल रखी है हमने. तो now write down the heading, the recombination of a spectrum of recombination of spectrum colors to give white light. Okay, just first understand what happens when the light passes from a glass prism. We know that when the light passes from the air into the glass prism, it disperses into its seven color due to the different speed of light in medium glass. So here the dispersion of light takes place, and at the bottom we find the violet color, at the top we find the red color. Okay, now again when it passes from glass into the air, this is the there is a small gap between these two prism. So again when it passes from the glass into the air, it dispersed light is here, and since we are placing a inverted glass prism here, so what will happen when this seven color light entered into the glass prism? Again it recombined to form the white light. It's really very interesting to understand. Okay, and we find the patch of the white light. This is not the patch of the seven colors light. This is the patch of the white light. So by this, recombination takes place when it passes from not the glass slab, these are the glass prism. Since the light is when the light is passes from the air into the glass, the dispersion of light takes place. Now again, what will happen if we are placing the inverted glass prism here? These seven color which the light these split seven color again recombine to form a white light. It work like a glass slab. What happens in the glass slab? What do you think? The white light don't split into seven color. It splits into seven color because in glass prism again the speed of light of different color has a different speed. But when it passes from this surface to this one, when it passes from here to here, what will happen? The recombination of the light takes place. So same in case of this one. The white light is split into seven color and it again recombine like it recombine in the glass slab. So again it recombine to form the white light. So it means we can again get the white light by using the glass prism if we place the one glass prism erect and the another one is inverted. So the second prism receive all these seven colors rays from the first prism and recombine into original beam of white light. Okay, and this is called the recombination of white light. Okay, so now the most important part of this one, this is the rainbow formation. Rainbow. So for understand how the rainbow is formed, first we should know how the dispersion of light takes place when it passes from the glass prism. So formation of rainbow. for this one, first try to understand what happened actually when the light passes from from denser to the rare medium. Okay, this is the denser medium, this is the rare medium. What will happen when the light is passes from denser into the rare medium? It bend away from the normal like this. You know it very well. Okay, now what will happen if we're going to increase this incident angle of incidence? Again, we are going to increase this angle of incidence. At any point, it can be like the refracted ray will be like on this path, है ना. हो सकता है ना कि आप इस एंगल को देखो बढ़ाते जा रहे हो तो क्या होगा, ये भी बढ़ता जाएगा. तो एक ऐसा भी आपको एंगल मिलेगा जिस पे ये एंगल 90 हो जाता है, यानी कि आपकी जो एमर्जेंट रे रिफ्रैक्टेड रे है वो परपेंडिकुलर निकल के जाती है, और इस एंगल को बोलते हैं क्रिटिकल एंगल. ये आपको सिर्फ समझना है. यू डोंट नीड टू राइट इट, but for understand the first functioning of rainbow formation you should know it. Again, what will happen if we increase this angle more than the critical angle? This is the critical angle at which the angle of refraction is of 90. And what happens if we increase this in the angle of incidence? The light is again refracted in its own medium. और ये तभी पॉसिबल है, देखो, जब डेंसर टू रेयर जाएगा. ये रेयर टू डेंसर में पॉसिबल ही नहीं है. जब लाइट रे डेंसर टू रेयर जाती है तो एक एंगल ऐसा भी आता है जिसके लिए जो आपकी रिफ्रैक्टेड रे है वो उसी मीडियम में वापस रिफ्लेक्ट हो जाती है. इसको बोलते हैं टोटल इंटरनल रिफ्लेक्शन. तो आपको ये पहले पता होना चाहिए, तभी आप रेनबो फॉर्मेशन समझ सकते हैं. ओके, नाउ द रेनबो फॉर्मेशन. दिस इज अ ड्रॉप ऑफ रेनबो, सॉरी नॉट द रेनबो, अ वाटर ड्रॉप. तो जब बारिश होती है, रेनबो फॉर्मेशन कब होता है? व्हेन द रेनिंग एंड द सनशाइन टेक्स प्लेस टुगेदर. दोनों चीज़ें एक साथ हो रही हैं तो रेनबो फॉर्मेशन होता है. तो देखो क्या होता है. First we should know what is the important condition for the formation of rainbow. Rainbow is formed only when there is a sunlight as well as a raindrops. तो बारिश भी हो रही है, बारिश ख़त्म भी हो जाती है तो कई बार क्या होता है कि एटमॉस्फेयर में बहुत सारी ड्रॉप्स, रेन ड्रॉप्स मॉइस्चर के फॉर्म में रहती हैं बहुत ज़्यादा, और सनशाइन भी है तो उस टाइम पे रेनबो फॉर्मेशन होता है. तो पहले आप डिफाइन लिख लेंगे. डेफिनेशन ऑफ रेनबो कुछ नहीं है, एक्सप्लेनेशन देखते हैं हम. देखो क्या होता है कि दिस इज़ अ लाइट रे विच इज़ कमिंग इनटू द रेन ड्रॉप. ये लाइट आ रही है रेन ड्रॉप की तरफ, ठीक है. यहाँ पे सन है. हैव यू नोटिस, अगर यहाँ पे सन है तो आपको हमेशा इस साइड में ही दिखाई देगा रेनबो, है ना, कभी सन के साइड नहीं दिखता. तो समझते हैं क्या होता है. तो दिस इज द सन एंड द लाइट इज कमिंग फ्रॉम द सन इनटू द रेन ड्रॉप. दिस इज द ओनली वन ड्रॉप. And we know that when the light passes from air into the water. Now this is water, this is not the glass. I have explained you that the dispersion of light not only takes place to the glass, it can be takes place by another medium, another optical medium like the water. So what happens when the light passes from the air into the water? It is split into its 7 color. Like this, we know that this is the dispersion of white light. Vibgyor. So this is the dispersion of white light, Vibgyor. Now here we know that water is a denser medium, air is a rarer medium. What happens? I explained you that when the light passes from the denser to the rarer medium, total internal reflection can take place. So it also happens in the rainbow. What happens? When the light is coming from the water into the air, the total internal reflection takes place. Since the water is a denser medium, air is a rarer medium. So here the total internal reflection takes place like this. So this is again the Vibgyor. And again, when the light passes from the denser into the rare medium, it bends away from the normal. So it should be like this. So we get the Vibgyor means the bend of the 7 color. Okay. So this is the formation of rainbow. Now please write down how the rainbow formation takes place. Write it down like this. A rainbow is produced. A rainbow is produced by the dispersion of white light white sunlight, actually white sunlight, by raindrop by raindrops in atmosphere. Okay, now the dispersion of white light takes place through the raindrop into the atmosphere. That's why the rainbow is formed. Each raindrop each raindrop act like a tiny glass prism. You understand the working of the glass prism? That's how the raindrop is work. Tiny glass prism. Okay, so the each raindrop is act like a tiny glass prism, splitting sunlight into a spectrum of light. So this is a rainbow, and this is the working of the only one raindrop, and lots of raindrop is there in atmosphere. So this continuous band which is formed by the different raindrops is called the rainbow. Now here is the explanation for the rainbow formation. Please write down the explanation of rainbow formation. Okay, as white light enter and leave the small raindrops the various colored rays present in various colored rays present in white light are refracted by different amounts due to which an arc of 7 colors called rainbow is formed in a sky. When a white light enters the raindrop undergoes refraction. Okay, is it clear to you? When the white light enter into the raindrop, it undergoes refraction. Okay, when the white light passes into the water, from air into the water, it undergo refraction. And dispersion to form a spectrum. Okay, and dispersion to form a spectrum. This is spectrum. I explained you this is spectrum of white light. This is spectrum. Again, uh, again, it undergo through the total internal reflection. And due to this total internal reflection, this rainbow is formed. To form a spectrum, this is spectrum. This is spectrum undergo total internal reflection. Always important point you should underline. Total internal reflection within the drop. Sorry. Within the drop. And finally refracted out. And this spectrum of produced by the raindrop in the atmosphere is known as the rainbow. Okay, this is the glass prism and the rainbow formation, and in next part we will study how the atmosphere refraction takes place. Okay, this is about the glass prism and the rainbow formation. Now next video we will understand how the atmospheric refraction takes place. Okay, till then, bye.